Hi, hello students, welcome to Let's Understand Physics. We all do our work during daytime and sleep at night. Why do you think it has been a routine for us? It is because during day we have sunlight and during night time we don't have sunlight. We use different sources of light. Am I correct? If there is power cut, we have darkness only. When you are in the dark room, what you will do? You will light again any candle. Because in that candle light, you can be able to identify the things. Correct? It is because the light will make you see the things. That's why from the olden days, we have this habit. As for the ancients, there is no other source of light. They are majorly dependent on sunlight only. Correct. Sunlight is very, very important for us. Why? Not only for us, even for plants, it is important. If there is no sunlight, there is no life on the earth. Am I correct? So, learning this light chapter is also very, very important for us. What do you say? By using different properties of light, nowadays we have so many entertainment programs as well. You might have seen Mirror Maze, Glass Palace. Correct? All those use some properties of light. Let's learn about light and main two properties of light in this chapter. They are reflection and refraction of light. Okay. Now, this sunlight what we have is source of light and it is the form of energy. What is energy? We can do some work with it. Correct. In class 9 also you have learned definition of energy. Now light will do. It makes us see things around us. If there is no light, we will not be able to identify the things. Correct. Now how it makes the things visible, we will learn. Before learning this, we will see some important basics of light chapter. Okay. Now see, from sun we get light. That means sun, what it is doing? It is producing light. Now the objects which produce light on their own are called as luminous objects. In luminous objects, we have two types. One is natural luminous objects and the other one is artificial luminous objects. In natural luminous objects, natural means what? It itself should be able to produce the light, like our sun. If you observe, different small insects have the ability to produce light. That means they glow. They are fireflies. You might have seen them. At least in films they will show. If not, just find out and see their images at least. Now, artificial luminous objects. They are the luminous objects man-made. Okay. They are bulbs, candles, all of them. Now, when there is light, we can see the things. But if you are in one room, if you would like to see what is happening on the road, you can see, correct? Many places, when we go for any trips, we feel this view, that view, lake view or sea view, correct? How they will design that room? They use glass, correct? Glass, what it does? It allows us to see what is there in the other side as well, correct? So these type of objects allow light to pass through them completely. They are called as transparent objects. Understood? So transparent objects means they allow light to pass through them. Example, glass, water, air. All these are transparent objects. Okay. Some objects will not allow light completely. That means you cannot see clearly, but you can at least be able to understand there are certain things. Like if you have sheer curtains or oil paper, butter paper, all those will just allow light partially. They also allow light, but they allow partially. Then they are called as translucent objects. Okay. Then some objects will not allow light. They block the light or they absorb the light. They are called as opaque objects. Understood? Now these objects, if you place them, you cannot see what is there at the other side. Okay? Now, when the light is there, how it travels? Some object should allow light, means the light is traveling. Correct? We'll see how the light travels. If you take a candle, just light it. Then take a small pipe, a straight pipe, and place your eye here and look into it. Now straight you will be able to see this light. Now the same pipe, if you bend, just bend the same pipe and observe the light. Then tell me, will you be able to see the light or not? The same pipe is bent. Now you are seeing. Now your vision is like this. You cannot see this light. Correct? That's why with this activity you will understand that light travels in a straight line. How does the light travel? It travels in a straight line. Very, very important. You have to remember this. Light always travels in a straight line. You have learned this when you have studied your 6th class. Understood? Now, when the light is traveling in the straight line, if there is an object which is transparent or translucent also, let us take both of them, what they will do? They will allow the light to pass through them. So here you have air, here you have glass. The light is simply going through that. Okay. Then when there is a opaque object placed, then what happens? Light rays you are taking. Now when the light rays are going like this, everywhere light travels, correct? What happens? This opaque object blocks this light. Now when this light is blocked, behind this there will be dark patch formed. There will be a dark patch formed. This dark patch is called shadow. Understood? When there is opaque object placed in the path of the light, there is a dark patch formed behind that object. That dark patch is called as shadow. Okay. Now, when we are taking source of light, that means from sun, we know what is source of light now. Correct? What is source of light? From where we get the light. From this source of light, we get different beams of light or different rays of light. Okay, whatever light we get from the source, we call it as a ray. Rays means simply a straight line. Light is traveling in the straight line, we have learned. This straight line, if you just take one single straight line of light from the source, this is called ray of light. Okay. If these rays you take a bundle from the source of light, so many rays you are taking, then these bundle of rays of light is called as beam of light. Okay? In this beam of light, if the rays are parallel to each other, if you observe, I have taken 4 rays, all the rays are parallel to each other, then it is said to be parallel beam of light. Understood? Now, from the same source of light, I am taking this is source. If you have the light moving from the same point into different directions, many directions, then this is called as divergent beam of light. Divergent beam of light. Then from many places, if the light is joined at one point like this, see the arrow marks. I am showing arrow marks to this point. From different places, the light rays are meeting at one point. This point is point of convergence. Okay, so this beam is called as convergent beam. They are meeting at that point, that is convergence. So it is called as convergent beam. Now here they are moving away, going in different directions from one point. So this is the point of divergence and the beam is said to be divergent beam. Okay, the source of light also will just take 2 types. Here in our chapter we take point source only. Here point source means a very small size source of light with a size of pinhead. It will be very small like this. We have extended source also. So when you take extended source, it is larger than the point size. Understood? Now what source we generally take? It is point source only. From point source we take divergent beam or parallel beam. Whenever we have to take parallel beam, we take the light rays are coming. The source is very far. Understood? The source is very far. Okay, now let's see. Now let's see the wavelength of light. Just remember, this is the extra point. Wavelength of light is, it is visible light, correct? The wavelength is 400 nanometer to 700 nanometer. You know nano means, what is nano? Very, very small, that is 10 power minus 9. Okay, just a small point. Remember this. Okay, now until here we will see in the simulator. Then we will understand with mirrors how light reacts. Okay. Now in the simulator we will see whatever we have learnt until. Let's see point source. So point source means it will be point and it is giving many light rays. Understood? Now here 360 degree we have light rays. From one point we have so many light rays, correct? Now this is point source and it is giving what type of light? From this the light rays are going, correct? From one point you have so many light rays going, that means it is called divergent beam, correct? Understood? This is divergent beam. Then we will go to another point source. It is less than 360 degree. That means it gives, observe here, it is giving in one direction the beam. So this is also same divergent beam only, and this is the point source. Understood? Now we will see light ray. Light ray is the single ray and it is straight line. Understood? Next, beam of light. Here beam of light. Observe here, many light rays are joined and they are parallel to each other. So this, what do we call? Parallel beam. I hope you understood. Now this parallel beam, if at all obstructed by a opaque material, what happens? Let us see. Okay. Now I am taking one blocker. Blocker means opaque material. It blocks the light. Correct. Now I am just taking a blocker here. Now see, wherever the opaque material is placed, there you have light blocked. Understood? Here light is blocked. Now here what happens? Shadow is formed. Correct? That opaque object's shadow is formed here. Understood? Now if I just remove this blocker and if I just take a glass. Glass means what? We have seen glass means it will allow the light to pass through it. Correct? Now I am just taking a glass. We can take a simple glass or lens, anything. Okay, so here I can take a circle as well. Observe here, I am just taking a circle. Glass is in the circular shape. Observe the light rays. They are passing through this. Understood? Through the glass they are passing. That is important for us. That means this is transparent surface. Understood? Then we have I have taken like this. Any glass you take, spherical lens. In the next video we will learn. So lens also, it is transparent medium. Observe the light rays are passing through the lens. Understood? So these are the basic things of light. Now we understood light is traveling in the straight line. What is point source? What are the different rays we have? We have learned. Now everything is fine, but how can we see the things with light? We can see the things when the light falls on the object. Object means anything, whatever we are able to see. Okay, now the sunlight falls on objects like tables, even human beings. Correct. Now, if you are taking example as table, if you are able to see this table, that means when the light is falling on the table, it reflects back and reaching your eye. Then only you will be able to see the things. If the light is not reaching your eye, you will be not able to see this particular object. Correct, right? If you are in one room, can you be able to see the things in the other room? No, right? Because on these objects also the light falls, but this light after reflection is not reaching your eyes. That's why you are not able to see those objects. Understood? Now, what is this reflection? And it is important, if there is no reflected light and if it is not reaching our eyes, we will be not able to see the things. Correct? Now, this is the natural phenomena of light. What is reflection? Let us see now. Reflection means bouncing back of light from the surface. Whatever light falls on the surface or the object, that light bounces back. How this bounces back? That is natural phenomena, but it has certain rules to reflect. They are called as laws of reflection. Let's learn laws of reflection now. For this, you can take any object, but here for this to take a surface, we take mirror. It is possible to take the laws of reflection on any surface. Okay, there is no problem. But we generally take the mirror so that we will learn what is mirror. Mirror is a glass. Okay, we'll take a smooth, shiny glass surface. Then what we will do is, for this glass surface, behind this, here front side, it will be smooth and shiny. Glass only. Okay. If you see in your houses also, wherever you are seeing, that will be glass only. But behind this, there will be coated with opaque material, and that side we call it as silvered surface. Understood? Front side, what do you have? Smooth and shiny glass surface, and glass is transparent, correct? Now behind that you have silvered surface coated with some opaque material. Why we are coating with opaque material? Because glass allow light to pass through it. If this opaque surface is not there, what happens? This glass will pass the light through this like this. But what we should have? We should have reflection. Reflection means what? Light has to bounce back. It should not go here. Instead, it has to bounce back. For that, what we are doing? We are coating here opaque material, because opaque is the blocker, correct? It should not allow the light to pass through it. Then only light will not have any path to pass here, so that it goes back. Understood? So this is the reason we take mirror like this. Understood? Now let's see how this reflection takes place and what are the laws of reflection. Understood? When you are taking a mirror, you just need to take a straight line. Whenever this smooth shiny surface, we call this surface as reflecting surface. What do we call? Reflecting surface. If this reflecting surface is flat, then this mirror is called as plane mirror. So what is called as plane mirror? When the reflecting surface is flat, then that mirror is called as plane mirror. Now I am just taking a plane mirror. Okay. Now we need source of light. From the source of light, we'll have light rays coming and falling on this surface. Now this light ray, which is from the source, that light ray is called as incident ray. Understood? This is called incident ray. Arrow mark you have to show towards the mirror. Name it as MM dash. I am taking MM dash as the mirror. That's all. And incident ray is denoted with letter capital I. And then it is touching at one point on the mirror, correct? This point is called as O. It is point of incidence. Incident ray is touching the mirror, so that is incidence, correct? So it is touching at one point, that's why that point is said to be point of incidence. Now at that point you have to take a normal. Normal means what? A perpendicular line to the mirror. Between normal and the mirror, the angle will be 90 degree. Understood? Now you will have a reflected ray. Will be here. It is moving away from the mirror. So arrow mark you have to show outwards, and this ray is called as reflected ray. Okay, it is called as reflected ray and the symbol is R. Now for normal it is N. If you measure the angle between incident ray and normal, this angle is called as angle of incidence, small I, and between normal and the reflected ray, this is called as angle of reflection, small r. Okay. Now, incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. That is the first law of reflection. Understood? What is the first law of reflection? Incident ray I, reflected ray R, normal N, all lie in the same plane at the point of incidence. Very, very important. With this only you are going to learn everything about reflection. Okay? And then second law is angle of incidence is always equal to angle of reflection. For any surface it may be, these laws are obeyed. Okay? Now we will see in a graph paper what is this actually. Okay. Now let me draw x-axis and y-axis. X, negative x, y, negative y. This you know, and this is what? Origin O. Correct. Now this is first quadrant. I am taking it as first plane, a second, third and fourth. Okay. Now from the source, let us take a light is falling on a mirror which is placed at the first plane. Okay, I have placed mirror here on the positive x-axis. Now the light ray I am taking here. This is incident ray. Then this is point of incidence, normal. How will be the reflected ray? To the other side of the normal. Correct. So here you have to take the reflected ray. Now observe here at the point of incidence, incident ray, normal and reflected ray. All the three are present in the first plane only. Correct? So that what we are telling? Incident ray, normal and reflected ray all lie in the same plane at the point of incidence. Understood? Now when you measure the angles, they will be equal. This I will show you in the simulator. You will understand how this will be working out. Okay. Now let's see by using mirror, reflection and laws of reflection. Now I am taking a mirror segment. This is the mirror. Okay, so we need to have incident ray. Before taking the incident ray, I will first take the normal. So for that we need a line, correct? For measuring, I am taking the protractor. Okay. Now this is the protractor. We'll just shift it here. Now let me take the 90-degree line here. Okay. Now let me just shift it here. Now if I take a line segment on this is 90-degree. This is the normal to the mirror. Correct? Understood? This I am just removing now. Now I will take from light source a single ray. Let the ray fall at this normal where it is touching the mirror. Okay. So this ray which is from the source, this is called incident ray, and this is the normal and this is the reflected ray. Correct? Now this is mirror M dash. When the light ray is incidenting at the point of incidence, it is reflecting back. Now let us measure the angle of incidence and the angle of reflection. Okay. Now let me measure them. Now this is, if you observe, see carefully. Exactly, it is not perpendicular. Let me just make it perpendicular. 1 second. Observe here. 90 it is showing down, correct? So if I place like this. Now see here, angle of incidence and angle of reflection, how it is. From 30 it is on the second line, and here also it is on the second line. So here also angle of incidence, see here, angle of incidence is showing angle I is equal to 32 degree, and angle of reflection, it is also showing angle of reflection, angle R is equal to 32 degree. So with this you will understand that angle of incidence is always equal to angle of reflection. Okay, if at all I take another single ray, and let me take that with the other angle at the same point of incidence I am taking, so that we will understand. Okay, now see here, both are at 60, understood? Both are at 60 degree. So here angle of incidence and angle of reflection, you will get 60 degree, understood? There is small difference because normal it is not exactly done. That's why a small light difference you will be able to see here. But whatever we have marked, everything is correct. Understood? So these are giving angle of incidence is equal to angle of reflection, and also incident ray, reflected ray and normal all lie in the same plane at the point of incidence. Okay, this is reflection of light by plane mirror. Understood? So, by seeing in the simulator, we understood that whenever the incident ray is normal to the mirror, normal means what? Making 90-degree angle with the mirror, the reflected ray will be on the same ray. That means reflected ray retraces its own path. It is because between normal and incident ray, what is the angle when there is normal incidence? Both of them are on the same line, correct? So angle is 0 degree. Then between normal and reflected ray, what should be the angle? 0 degree only, correct? Now, when both of them are 0 degree, 0 means same line. That's why when there is normal incidence, incident ray, reflected ray and normal all lie in the same plane. Okay. Now, let's see, when we have parallel incident rays on a smooth surface, what happens? For parallel incident rays. Parallel incident rays means you need to take parallel beam of light. That's all. Now I am taking parallel beam of light. Okay. I1, I2 and I3 are the three rays and O1, O2, O3 are the point of incidences. Then you have N1, N2, N3 are the normals. When there is parallel beam, angle of incidence for all the three rays will be equal. Am I correct? Now angle of reflection, that means here when you take here angle I1, angle I2 and angle I3, they will be equal. Understood? Equal means that is the meaning. Now reflected rays will be, see here, I am just showing with the different color. In reflection you will not have different color. Okay. Now what is I1 we have, the same will be R1. What is I2 we have, the same will be R2. Whatever I3 value we have, the same will be R3. So R1 is equal to R2 is equal to R3. Correct? Because I1, I2, I3 if they are equal, angle R1. So small letters you have to write. Angle R3, they will be equal. So this type of reflection is called as regular reflection. That means for parallel incident rays, the reflected rays also will be parallel. This is called regular reflection. In this, anyhow, laws of reflection are obeyed. If at all you are not taking mirror, if you take any other surface, like as we have discussed, any object if at all we have to see, there will be reflection taking place. Like table we take. How much ever smooth it is, we have some grooves, some irregularities will be there. Minute, like this. Okay. Now on this, if I take parallel beam of light, now observe what happens with the normals first, because normals are the important thing here. Okay, now this is the point we have. For this, if you take the normal, it is like this. For this point, this is O1 and this is N1. Okay. For this point, if you take normal will be on this only, N2 and O2. For this, normal you have to draw like this because this is the point of incidence, O3 and N3. Understood? Now tell me, what happens to the reflected rays? Now first N1, this is I1, then I2, R1 we draw first. With this is the first reflected ray and this is the angle of reflection for the first ray, R1. Now where will be reflected ray for the second incident ray? When this is normal incidence, it must be here only on the same. This is R2. Understood? Now where will be third reflected ray? Here. Now observe R1, R2, R3, how they are. Are they parallel? No, they are moving in different directions. Correct. This type of reflection is called as irregular or diffused reflection. Understood? Irregular or diffused reflection. Now, in this reflection also, laws of reflection obeyed. Here the angles are equal and they are on the same plane. You can see that. Correct. But what is happening as the incident rays are incidenting on different positions, their normals are shifted. In regular reflection, if you see, normals are parallel to each other. But here, normals are not parallel to each other. According to normal only, we will have reflected ray. Understood? Now, the reflected rays are in different directions. That's why, due to this irregular reflection only, we can be able to see different things from different positions. Understood? Here we will not have one ray. Actually, we cannot take two rays, three rays, correct? From sun, so many rays will be falling. Here you will have some bundle of rays. Here also like that. Incident rays also will be there. And here also like this. So much light will be there. So if you just see here also, from here also, from here also, from any position, you will be able to identify the object which is here. Understood? That is the advantage of irregular or diffused reflection. Okay. Then let's see when we take a single ray on the mirror which is incidenting normally. Now this is the mirror segment. Now I am taking, first let me take the protractor and we will draw the normal first. Okay. Now this is the protractor we have and let me shift it here. Both the sides you have to observe that the 90 degree is touching the line. But we will have small difference because we are not able to take it as a straight line. Correct? Understood what I am telling? We are not actually taking mirror as straight as we can do. So there is small slight difference here. Correct? Now see here there is small difference. So that small difference may cause you some trouble. Let us see. First, let us draw the normal. Okay. Let me draw the normal first by taking line segment. I am drawing the normal. Okay. Then now what I will do is I will take the single ray. Let this single ray fall on the mirror. If you observe, it is trying to trace its own path. Now it is not exactly on the normal, that's why there is a small angle shown. Now let me just shift it so that it will exactly retraces its own path. Okay. Correct. Now observe here. When the light ray is incidenting on normal, incident ray, reflected ray and normal at the point of incidence on the same line you can see. So here if you take the angles, angle I is equal to angle R and both of them equal to 0 degree because angles are always measured from the normal. Don't forget. Okay. Now we will see what happens when we have regular reflection. Okay. Understood? When we have regular reflection, what happens we will say. For regular reflection also I am taking a mirror segment and I will take the parallel beam of light now directly. Now let me take the parallel beam of light. Okay. Now if you measure the angle between the incident rays and reflected rays, you will have this is I1 and this is R1, correct? Here you will have normal. If you measure the angle, this I1 will be equal to R1. In the same way, this is I2 ray and this is R2 ray. Whenever you have, if you measure the angles, angle I2 will be equal to angle R2. Understood? Now what I will do is, I will just decrease the ray density. Okay, that means here the rays are having very small distance, right? We will take the rays with some large distance. Okay. Now observe here, ray density I am just decreasing. Now let me take the beam. I am taking only 2 rays. Then you will have only 2 normals and 2 angles. Correct. If you measure them, you will have, let me just take, for sample I am taking, this is what? N1 and this is N2. Okay, now if you measure the angles, I1 and R1 and I2 and R2 you can take, right, rays. What is this? I1 and this is R1. This is I2 and this is R2. Understood? Now let me take the protractor. Protractor I am taking. Okay, so let us shift this protractor here. Just understand by simply placing this. If there is small difference, no problem. Until and unless you don't have, I'm first placing 0 point, then only we will understand whether we have normal correctly or not. Okay. I am placing this one here. Yes. This one let me take. 0 I am pointing. Now check with the angle. Observe here. With blue light I'll do with green light so that it will be easy. Now this is the angle of incidence. For 30, one number before it is. Now here also if you observe, for 30, one number before you have. Observe carefully. Understood? See here only. Now here. For 30, one number, and here also for 30, one number before. That means you can take it as like almost 28 degree or 27 degree. Understood? The same thing, I will just shift this protractor. Okay. Let me shift the protractor to this normal. Now also observe the same angle. Understood? For 30, one number before, and here also for 30, one number before. Normal should be exactly placed. That is very, very important. If the normal is a bit tilted, that means if that is not exactly pointed with 90 degree, then you will have slight difference. I have here slight difference, but it is okay. Now see here, have you observed, if I am taking for the first case also angle I1 equal to some 28 degree, R1 is also equal to 28 degree only, and angle I2 is also equal to 28 degree only. So angle R2 is also equal to 28 degree only. Understood? So this is what regular reflection is. I hope you understood this concept. So here for parallel incident rays, the reflected rays will be parallel. Understood? Now we are able to see the objects by irregular reflection. How can we see our image in the plane mirror? We can see our image, correct? And that will be same like us only. Correct? Then what is required to get the image in the plane mirror, we will see. Now whenever image we are getting, there is an object. That particular object's image only we can see in the mirror. Now here object means from where we take the light rays. That's all. Okay. So this object will be a point of intersection of incident rays. Intersection of incident rays. So from this only we take all the incident rays. That is object. We generally take a small size object, like our objects will be with a single dimension or point size. If we are taking object as point size, then that object is called as point sized object. Okay. Otherwise we just take with one single dimension like height. It will be vertically placed like this, how we stand in front of the mirror. Understood? So this also we just consider as object. Understood? Now let us see, by taking a point object, how we get the image in the plane mirror. Now I am just taking a plane mirror. In front of that I will place an object O. Okay. Now I am taking rays from the object. If I have to get image, minimum 2 rays are required. How this object is point of intersection of incident rays, image will be formed with intersection of reflected rays. Okay. Now let us see incident rays falling on the mirror, what happens. Now one ray I am taking normal incidence. You know what is normal incidence already. Then see, here you have I, here you have R and N also. Understood? Then one more I am just taking here with certain angle. Then how will be the reflected ray? Like this, correct? This is I2. Here let us take this as I1 and this is R1. This is R2. Now if you observe, R1 and R2 are moving in different directions. If you just extend also, see here, this is going in different direction and this is going in different direction. Both R1 and R2 if you observe. Is there any possibility that this one and this one meet in reality? No, they cannot meet. So that what we can do? If they are not meeting, there won't be any image formed. Okay. Now, as they don't meet in reality, what we have to do is we have to extend them behind the mirror. Just reflected rays, extend them behind the mirror. I'm just extending. Okay. Now, see here. After extension, they are meeting here. Okay. Now, as they are meeting here, what happens here? Image will be formed. This is the image formed of this point object. This is what object O I have taken. Now this image is formed due to the extension of reflected rays. That's why this image is called virtual image. Really they don't meet. That's why we have extended behind the mirror and we are calling it as virtual image. Now image means it is the point of intersection of reflected rays. But whenever reflected rays are extended behind the mirror and it is forming image, that is called virtual image. Understood? Now there will be different characteristics of this image. Let us learn them. Okay, for learning it, we'll just take one graph paper again. Then I'm just taking a plane mirror. Same thing, take any object here at this place. Okay, in front of the mirror, fourth box I have taken. Now take the rays, whatever I have taken, now the same rays I am taking. This is R1, I1, and then one more I will take here, and then if you observe the same angle I have to draw. That's all. Okay. Now this is I2 and R2. Let me extend them behind the mirror with some different color. I am just extending. Okay. Now if you observe, check this, where you got the image. This is object, right? This is image. Now if you observe carefully, this is the first box, second box, third box and fourth box. Now this is also same, first, second, third, fourth. Understood? At the fourth box only you have image formed. Now from this mirror, if you measure this distance, and from the mirror to image if you measure, this distances will be equal. Generally from the mirror to object, the distance is called object distance, denoted with letter U. And from mirror to image, the distance is called image distance and denoted with letter V. Okay. If you observe, the distances are equal. And the sizes also you observe, they will be equal. Understood? The same size you can see in the mirror. If you stand yourself also, you can observe, or you take any small object in your hand also, it will be same. Understood? These are the two characteristics. The distance, object distance and image distance will be equal, and the size of the object is equal to size of image. Understood? And it is virtual image and it will be erect. Erect means what? Same, straight. However you stand in front of the mirror, your image also will stand like that only. That is called erect. And the size is same size. Very, very important. And then one very, very important characteristic of this image is, the image is, what happens if you just raise your right hand, stand in front of the mirror and raise your right hand. In your image, it is seen like the image is lifting left hand. Am I correct? So this property, this characteristic of this virtual image is called as lateral inversion. What is this called? Lateral inversion. That means sides will have difference. They will be inverted. Left appears as right and right appears as left. That is the phenomenon of lateral inversion. Understood? These are the characteristics of image. Let's see image formation by a plane mirror. Now I am just taking a mirror segment. Okay, this is the mirror. Now let me take an object like point size object in front of the mirror. Then I'll just take one ruler. Okay. Let me first take the ruler. Ruler I am just placing here. I'll just shift it like 300 millimeter, like 3 centimeter you can take. Understood? Now let me take an object here at 0. Now its image, this is what? Object. Its image I would like to see how it will be formed in the plane mirror. Plane mirror is M dash. Understood? Now for this what we have to take? We need minimum of 2 rays. Correct? We need what? Minimum of 2 rays. Then one ray I am just taking normal to the mirror. Okay. Let it be at 300 only. Normal to the mirror. Normal to the mirror means we know it has to retrace its own path. Now this is retracing its own path, and then if I am taking one more beam from the same object here, let me first take the first ray which is retracing its own path correctly. Okay, and now I will take one more light ray. Okay, touching the mirror at some angle. Now I will just shift it. Okay, let me just shift it here. The same ray I just need to shift, so that only we will get easily. Okay. Okay, let it be like this. Now the reflected rays we need to extend. Correct? Let us extend the reflected rays. I am taking one more color so that it will be easy for us. Straight line only we have to draw. Okay. Now, if you observe this ray, where they are meeting? They are meeting at 600. This is the place where image is formed. Correct. If I'm just taking a straight line, how it would be? Okay. Let me take the line segment. Now I will extend this here. Okay. And then this incident ray we have read, second one, its reflected ray also I will be extending. Now see here, they are meeting here somewhere. That means it is almost 600 millimeter. We can take a 6 centimeter we can take. So this is the place where you will have image formed. Understood? So this image is formed behind the mirror. So it is called as virtual image. How it is called? Virtual image. And how it will be? It will be of same size. Very, very important. So plane mirror forms same size image and it is virtual in nature. Now this image, can you take it on any screen? No. Okay, so virtual images cannot be taken on screen. That means like on any paper, or if you have any wooden screen, on that also we cannot take. Understood? So remember this image formation by the plane mirror and the characteristics of image. Okay? Here practically you have seen the distances from mirror. When you measure, they will be equal. Understood? So size also will be same. Generally we regularly see our image in the mirror. Now with plane mirror everything is fine. But we see if you go to saloons or makeup rooms, they don't have this plane mirror. They will have a separate mirror. If you go to dentist also, you can see that type of mirror where if for example in makeup room your face will become very big. If your face is this size, it shows a larger image like this, so that it will be easy for makeup artists to do makeup. It will be evenly done. In the same way, if you go to metro stations or in apartments also, some places of parking, we have a very big mirror placed. In that mirror, you can see vehicles like very small, many vehicles you can see in that. Have you observed these two types of mirrors? In our houses also, we can see different vessels. Outside of the vessel, like this, if you have a vessel, outside of this you will see your image in one way, and inside if you see, it shows another way. Mainly if you have a spoon, the spoon, whatever the curved surface you have there, you will see your image in one way, and if you turn it, it shows the other way. Have you observed all these things? If not, observe them. Okay. Why is it so? Why we have to use the mirrors like this? Let's learn now. They are not plain mirrors like us. They will generally have the reflecting surface curved. In plane mirror, what we have learnt? Reflecting surface must be flat, correct? But all these will have reflecting surface curved or bent. It will be bent inwards or outwards. That is secondary, but they are curved. So those mirrors we call it as curved mirrors or spherical mirrors. So as the name suggests, those spherical mirrors are made up of sphere, and this sphere is also made up of glass only. So we just need to take glass sphere. I'm not showing the 3D diagram. We'll take for our representation circle. Okay, for sphere we just take the representation as circle. Okay. Now we have a sphere like this made up of glass. Now what we will do is, we just need to take some portion like this, only this part from here, hollow sphere. Okay, inside you will not have anything, it is hollow only. Okay, generally sphere will have center, and from center if you join any part, any point, that is radius. Correct, this you know. Now this curve if I take, and what I will do is, how we have taken silvered surface, the same way outside if it is silvered, inside it is smooth shiny reflecting surface only. Okay, and outside it is silvered. Then this mirror which has reflecting surface curved inwards, we call this mirror as concave mirror. Understood? And in the same way, I just take this side as well. Okay, the other half part. Take this, and what you will do is, curve outwards is reflecting surface, and this side is silvered surface. Understood? Now the reflecting surface is bulged outwards. This mirror is called as convex mirror. Okay. Now in these two mirrors we have different applications. Before this, image formations we have learned for plane mirror. Correct. Now for this, how will be images formed? For that we have to learn certain terminology of spherical mirrors and then some ray rules. Then we will learn image formation, and we will see in the simulator as well. Understood? Now first one, terminology. Very easy, in the same way very important. Understood? As we know, we have sphere. I'm taking. It has center. Correct. Now our spherical mirrors are part of this sphere only. Correct. They are from this sphere we have taken. So if the curves joined like this, they form sphere only. Now this center, whatever the sphere has, the same center they will have here and here. Correct. For concave mirror it is in front of the mirror, and for convex mirror it is behind the mirror. Correct. So now this center of the sphere is called as center of curvature, because mirror M dash if you take, that is the small curve of the sphere. Correct. Now due to this curvature we call this center as center of curvature. Now the M dash whatever you have, it is reflecting surface. The width of this reflecting surface is called as, what is this? Width of reflecting surface is called as aperture. For both of them same. Okay. Understood? The midpoint of this aperture, the mirror. Here we have midpoint, right? This midpoint is called as pole, represented with letter P. For this is the pole. Okay. Now join center of curvature and pole. For both the mirrors, if you join, this is called as radius of curvature, represented with letter R. Understood? The distance between center of curvature to pole is called as radius of curvature, and it is represented with letter R. And any radius you take from center, if you join anywhere, that will be radius only, correct? In sphere we know. So any radius you take, this radius will act as normal. How does this act? Normal. Because in reflection, the main part is what? Finding the normal. If you know the normal, you will be able to identify the angles and able to draw the reflected ray. So here in spherical mirror, how do you identify the normal? Whatever the line passing through center of curvature, that will act as normal. That's all. Very, very important point. You have to remember this. And if you just take one imaginary line passing through center of curvature and pole, okay, that is the line passing through center of curvature and pole, this line we call it as principal axis. What do we call? Principal axis. Understood? These are the main important terms of spherical mirrors, and one more term is there that you will learn with ray rules. Okay. Now, concave mirror definition we have learnt. But there is one more name for concave mirror. Why that name comes, we will see in the simulator and we will understand. Okay. Now plane mirror we have seen, it has reflecting surface flat, correct? Now let us see a mirror which has reflecting surface curved. It will be like this. Understood? So whenever the reflecting surface curved inwards, this is the reflecting surface. This is the reflecting surface. Then we say this mirror as concave mirror. Okay. Now, what is the concave mirror and why it is called as concave mirror, and the other name of concave mirror we will see now. Okay. Now, let me take a beam falling on the concave mirror. Okay. Now, see here how many light rays I have taken. I have taken a parallel beam. Now, these are the incident rays. Okay. See here. These are the incident rays which are parallel. Now, these are the reflected rays. They are touching the mirror here and they are reflecting back. Understood? Now, after reflecting, they are meeting at this point. This point will form image. For example, if at all we take sun here, sun's rays are falling on the concave mirror. Now you just take one paper placed here and arrange that all the reflected rays are meeting at one point, right? This point will be formed on that paper. That point is what? Image. This image, which is very small image, like point size image, which is forming on this paper. So here so many light rays after reflection are concentrated. Understood? So due to this concentration, this paper starts burning. Understood? So here what it is doing? The light rays are meeting at one point, are converging at one point. So this mirror is called as converging mirror. What it is called? Converging mirror. Understood? So this is concave mirror. Now let us see another mirror, which is convex mirror. Understood? Let me just remove this. I'll again take convex mirror. Now, how should be the convex mirror? Here, the reflecting surface should be bulged. So, this is the reflecting surface. Understood? Now, this reflecting surface, what it does when there is parallel beam of light falling on it, we will see. Okay. I'm taking again parallel beam of light falling on convex mirror. Observe here, you can see incident rays and reflected rays. These are the incident rays, correct? And these are the reflected rays. In concave mirror, we have seen these reflected rays are meeting at one point somewhere here. But here, are they meeting? No, they are actually diverged. They are going in different directions. See here. This is the range of reflected rays. Understood? So what is the imaginary sphere we have for concave mirror? Here. Understood? Now the center will be here. Now if you extend these reflected rays, just extend them. Okay, like this. If you just extend them, they will be meeting at one point. So this point where they meet, this point is called focus. Understood? But this point is formed because of the extension. That's why this focus is called as virtual focus. In the concave mirror where you have seen, that is actually meeting, the reflected rays are actually meeting somewhere in front of the mirror, correct? We'll see that now. Okay. Let me take now concave mirror and observe. They are meeting at one point. So this point of intersection, so this is also called focus. But it is forming due to the real intersection of reflected rays. So this is called real focus. Now for this, where is the center you will have? Where is the center we will have? Observe here. This is the sphere, correct? This is the sphere. This is the sphere. So as you have focus here, you will have center here. Understood? So we have the midpoint, now this is M dash. So this M dash, this is taken as aperture. Okay. And this is from center to midpoint. If you mark, this is taken as pole. And this focus point exactly bisects this line, which is radius. So from focus to pole, whatever you have, that will be taken as focal length. Now this radius will be equal to 2 times of focal length. You will understand in the video. Okay, first you see in the video also. This will be explained clearly. For the convex mirror also you have the same thing. So now you understood that when there is parallel beam of light, you just need to mark pole, center, and this is what? Principal axis. So when there is parallel beam of light means parallel to principal axis. When there is parallel beam of light, after reflection, it is meeting at one point on the principal axis. That we have seen now. Why the light rays are meeting at that point, we will see now. Okay. Now let me tell you, when we have incident rays like I1, I2, I3, I4, as I have taken 4 now. For drawing reflected ray, what do we need? We need to first know normal, and we have to draw normal at point of incidence, correct? Now these are the point of incidence. Let me draw the normal. Now just now we have learned normal means joining from the center. I am just joining from the center, see here. Just for this I have drawn. Now reflected ray I will draw. This is the reflected ray. R2. Okay. The same way if you draw for everything. That means I2 you have drawn. I1, I3, I4 also you draw. You will have all the reflected rays meeting at one point. I will just use different color so that it will be easy for you. Okay. Now see here, for this, and for this if you draw, they will be meeting at this point. What is this point called now? This point is called as focus, represented with letter capital F, and this point will be bisecting the radius of curvature. The distance between focus and pole is called as focal length. Very, very important. Distance between focus and pole is called as focal length, denoted with letter small f. Okay. And this point will bisect the radius of curvature, means it makes two equal parts, so that you will have R equal to 2f. Radius of curvature is equal to 2 times of focal length. Understood? Now see here. For this concave mirror we have learned. Whenever you have a point where so many reflected rays meeting, this is the point made up of so many reflected rays. Now when the reflected rays are meeting, that point is what? Image. Correct? Image we have learned, that is the point of intersection of reflected rays. Now here image is formed from a light source. As we are taking parallel light rays, here we can take it as sun. So a very small image of sun is formed, so that at this place, if you just take a paper, this paper starts burning due to this image of the sun. Understood? So here reflected rays are converging. That's why this mirror is called converging mirror. The light rays, after reflection, they are converging at that point. Correct? That's why this mirror is called what? Converging mirror. Understood? Now the parallel rays, what we have seen in the simulator, they are, let us take them as from sun. They are meeting at one point, right? There you place one paper. Then that paper starts burning due to the small image formed on that paper. That image is sun's image. Understood? Now let's learn ray rules of concave mirror. First we will see for concave mirror, then we will see for convex mirror. Okay, first ray rule. First rule is light ray. Here light ray, if I say, that is incident ray, is parallel to principal axis. Light ray parallel to principal axis, or you can take it as incident ray parallel to principal axis. Okay. What is principal axis? You know now. So when you draw these, you have to take the mirror, its silvered surface, and then the points. What are the points? Pole, focus, and center. Okay. Then one light ray, if you take, what happens? Just now we have learnt it passes through focus. So this is I and this is R. Where is the normal? Through center of curvature you have to draw. If you measure the angles, they will be equal. Understood? This is the point of incidence. This is the first ray rule. And the second ray rule is exactly opposite to this. When the incident ray is passing through focus, then what do we have? Same, you have to take the mirror, mark the points, pole, focus, and center. Now take the incident ray is passing through focus point. This is I. Now draw the normal. This is the normal. How will be the reflected ray? Exactly parallel to the principal axis. This is the reflected ray. Understood? Then third one. Here incident ray is passing through center of curvature. Center of curvature C. Then draw the mirror. Then mark the points pole, focus, and center. Then incident ray is through center. Then this is incident ray. Now where is the normal? This is normal itself. Correct? Then where will be the reflected ray? On the same line, So whenever the incident ray is through center, reflected ray retraces, means it stays on the same line. So retraces its own path. Then fourth one, incident ray at pole. When you have incident ray incidenting at pole of the concave mirror. Principal axis, then pole, focus and center. Now see here, light ray is incidenting on pole here. This is incident ray. Now where is the normal? Normal is principal axis itself or radius itself. This is the normal because this is the line which is passing through center, correct? Now where will be the reflected ray? It should be the other side of the normal. So one side you have incident ray. So here the other side you will have reflected ray. This is R. Understood? Here reflected ray will be the other side of the principal axis. Understood? So this is the fourth ray rule. Then let us see ray rules for convex mirror. Then we'll see in the simulator. Same 4 rules you have, but here there is a small difference you should identify and remember carefully. Now convex mirror means we should have like this, correct? Now this is the principal axis. For convex mirror, where will be center? Behind the mirror. Here you have center, here you have focus and here you have pole. Okay. Now why this focus is here, we will see first. Okay. Now for focus, same, you have to take parallel rays to the principal axis. Then if I1, I2, I3 and I4, only 4 we will take. Then normal, how do you draw now? From behind the mirror only we have to draw. So through center only. Okay. There won't be any change. I'm just drawing here. Okay. Let me draw for 3. Then how will be the reflected ray? It will be here. The other side of normal I am drawing. See carefully. It will be here. Correct. Now all these reflected rays R1, R2, R4 and R3 will be here. R3. Then if you observe them, are they going in the same direction? No, they are going in different directions. So there is no possibility they meet at any point. So what we have done in the plane mirror? We have extended them behind the mirror. Now these also I am extending them behind the mirror. If you observe, if you draw carefully, it will come. Okay. Now this is the point where they are meeting. This point is called as focus. But this focus is formed due to the extension of reflected rays. So this focus is virtual focus. In concave mirror, we have real focus and here we have virtual focus. Anyhow, that will be taken as focus point only. And here also it bisects the radius. So R is equal to 2F. Here also it is correct. Understood? Now if you observe, these reflected rays are seen like they are moving away from the same point. Correct? So these reflected rays are considered as beam and they are moving from the same point in different directions. So this beam is called as divergent beam. How this is called? Divergent beam. So this mirror is called as divergent mirror. Understood? Now let us see the ray rules. Anyhow, first ray rule is incident ray parallel to principal axis. Parallel to principal axis. Okay. Now draw the mirror. Principal axis. Mark pole, focus and center. Incident ray parallel to principal axis I. Now what is the normal? Draw here. Correct. Now what is the reflected ray? It will be like this. So join it behind the mirror. You will have a point. That point is focus. So here the reflected ray is appearing to pass from the focus. That means it appears there in concave mirror. It is actually passing through focus. But here what is happening? It is appearing that it is moving from the focus. Understood? So that is the first ray rule. Then second one, same, you have to take opposite. The light ray which is appearing through the focus. Understood? Incident ray is appearing to pass through focus. Then after reflection, what happens? Observe. Pole, focus and center. Then this appearing means how do you draw? I'm just extending first behind the mirror and from the mirror I will take the straight line here. This is I. Now normal, same, you have to take from the center. Use the scale, you get correctly. Okay. And let me draw the reflected ray from the point of incidence. It will be like this. This is the reflected ray. Understood? If you measure here angle I and angle R, they will be equal. Okay. So whatever you have learned in concave, the same thing, but you just need to see where you are taking the silver surface and the points. Okay. Now let's see third one. Incident ray is appearing to pass through center. Center of curvature. Then pole, focus and center. When you are drawing, just take equal distances like 2 centimeter and 2 centimeter or 3 centimeter and 3 centimeter. Okay, because they are equal distances. Correct. Now, the light ray is appearing to pass through center of curvature. So, this is the light ray. Incident ray, normal and the reflected ray will be on the same line. So here also through C only it is normal. So when this is normal incidence, we have reflected ray on the incident ray itself. Understood? The fourth one, incident ray striking at pole. Incident ray is striking at pole. Here also you will have same thing. Pole, focus and center. Incident ray I am taking at pole. Now observe what is the principal axis here. This is acting like normal, correct? Because it is passing through center. How will be the reflected ray? It will be in the other side of the principal axis. So here you will have reflected ray. If you measure angles, angle I and angle R will be equal with respect to the principal axis because that is the normal. Understood? These are the ray rules of spherical mirrors. By using these ray rules, we take the image formation by the spherical mirrors. We learn along with the image their characteristics and also what is the application we have. Okay. Now let us understand the ray rules for spherical mirrors. Now let me take the mirror. First we will see for concave mirror. Okay. Now with parallel beam we have seen. Now also I am just taking parallel beam only. With one ray also it will be passing through the same point, and if you take n number of rays also they all take the same point. Now this is the focus point. Now I will just take one line segment passing through the focus. Okay, so this line segment we have learned what it is. It is, what is this? Principal axis. Understood? Now you know this is focus. Correct. Now let me take the ruler and we will just measure the distance from pole. This is pole, right? We need somewhere center of curvature. So from pole to focus, what is the distance? Perpendicular distance. This is the perpendicular distance. If you measure the distance, you will get the focal length. Okay. Now let me see. I am just taking ruler. Okay. This is the ruler. I will shift here. From focus to pole, it is showing somewhere 60. Correct? 10, 20, 30, 40, 50, 60. 70, 80, 90, 100, right? So 60 millimeter let us take. Now from center to focus also you should have the same 60 centimeter. Understood? Now let me just mark this as center. Understood? Center. Now we will see the ray rules now. For parallel ray to principal axis, you have seen that. Again I am not showing now, but now what we will see is passing through focus. What happens? Focus is at 60. Remember that. A single ray I am just taking, and let me take the light ray passing through focus. That means 60. Observe here. It is almost parallel to the principal axis. Why we are not getting parallel to principal axis is because this line is not exactly straight. That's why we may not get correctly, but it will be parallel to. I'll just shift the mirror otherwise. See here. Now see. This will be parallel to principal axis. Understood? Now the same one more, through center of curvature if I take this, did you understand? This is passing through focus and the light ray is parallel to principal axis. This is incident ray and this is reflected ray. Understood till here? This is the second ray rule. And let us see the third ray rule. Okay. What I am doing is, third one is passing through center of curvature, right? I'll take the single ray again. Let me take this as passing through center of curvature. So this one. If you observe, it is retracing its own path, correct? Exactly. Now see here, it is retracing its own path. If I take at 0. Understood? So this is taken as the light ray which is incidenting through center of curvature. Because through center of curvature, if the light ray is incidenting, that is normal incidence in the any mirror like spherical mirror, concave or convex. This is I and this is R and this is the normal. Understood? So this is the third ray rule. Whenever the light ray incidents through center of curvature, it retraces its own path. Now let us see the fourth ray rule. Okay. That is striking at pole. This is easy only. Now see here. Let me take striking at pole. Is it striking at pole? Yes. Understood? Now if you just take the protractor, how we have seen in plane mirror, the same way we have to observe. See here, this principal axis itself will act as normal, correct? This is normal now because this is the line which we have passing through center. Now measure and check the angles. Now let me just check the angle by placing it correctly. I am placing 120. If I place 120, this other side it has to touch the 60. Then only it is correctly I have placed. Understood? If I at all it is not showing correctly, that means the line which we have drawn is not straight. Understood? Now see here. Let me take 0 so that it will be easy for us to take. If I place here 0, actually it has to take 180. But check here, it is not taking 180 degree, correct? If at all I would like to shift it, one second. Let me just draw one more line. Okay. Line I will take. Sorry. It has to pass through 0 and then it has to pass through 180. So this is the correct normal. That means principal axis. Okay. Now let me shift this light ray here. Okay. Now I am just removing this ruler. Now see the angles 30 and 30. Otherwise we will just change this mirror so that we will get correctly. Okay, so for now for this is the normal. Okay, observe here the angles are correctly marked. Understood? This is angle I and this is angle R because this is incident ray and this is reflected ray. Understood? Now this is the imaginary sphere and center will be somewhere in the middle. Understood? These are the 4 ray rules of concave mirror. Then we will do for convex mirror as well. Okay. Let me just take for convex mirror. Same ray rules. I am just changing it into convex mirror. This is the convex mirror, correct? Now, parallel ray to the principal axis we have to take. So for principal axis I am just taking one line segment. Then if at all I take parallel ray with single ray, parallel ray. For parallel we'll take beam, correct? First let me just expand it so that let me just extend this. So this will be focus. Now let me do with beam. Okay. Now see here. You just need to take until mirror only. Okay. Now if you join everything, they have to meet at one point. Take the reflected rays. Now here itself, let me show you the center also, because we have one light ray which is retracing its own path. Here appearing is required. So if this is focus, when you have parallel beam of light, it is like it is showing you that after reflection they will be diverging or they appear to pass through focus. Understood? Now the second ray rule is, let me take the second ray beam. I am just removing. Okay, let me remove the beam. I have just one single light ray, but this also I am just removing because incident ray I have taken parallel. Now what I will do is, let me just take one point focus like this. Let me just take focus like this. Okay. Then what I will do is, I will just think one single light ray which is like passing through that point. Now see here, it will be parallel to the principal axis. Now where is the focus? This is the focus. Understood? The light ray which is appearing through, passing through focus means after reflection what happens? It will be parallel to the principal axis. Now if you have center here, the normal you will have like this. This will be the normal. Understood? Now let me take the light ray which is appearing to pass through center of curvature. Understood? If the light ray is appearing to pass through the center of curvature, it will be retracing its own path. Observe here. It is retracing its own path. Now, for this, where do you have center? This will be center. And somewhere here you got focus. Correct? Understood? Then, let us take the light ray which is striking at pole of the convex mirror. We know, right? I'm just taking it is striking at the pole. So somewhere here, this one. That means actually this is not the pole. That is not the midpoint, correct? If this is the mirror, this will be the pole. Now let me take the protractor to measure the angles. If there is any small difference, just don't get confused, because small differences you will have, because we cannot take lines straight, correct? I'm just taking the protractor. Let me shift this here. If you have 0, 180 must be there, correct? Now see here the angles. Here also you have same angle. Did you understand? It is showing here 29 degree and here also it is showing here 29 degree. Understood? So now this is acting like principal axis and normal. Okay? And normal. Understood? So whenever the incident ray strikes at the pole of the mirror, then it reflects back with the same angle in the opposite side of the principal axis. Understood? These are the ray rules of concave mirror and convex mirror. I hope you all understood this. You can try with different angles so that you will understand. You just take a spoon in your hand and stretch your hand. Place the spoon's curved inwards surface in front of your face and bring the spoon by folding your hand near to your face. Have you observed any change in the image, the size majorly? It actually changes. So, with respect to the distance from the mirror, the size of the image and the position of the image will be changing. Let's see what are those different positions of objects and the images, and what are the characteristics we have, and what is the application for that. Where do we use those positions actually? Let's learn them. First one, object. This is for concave mirror. Okay. Object at infinity. Infinity means which is very far. Let us take the object as sun. It will be important for MCQ. In the options, if sun is there, far object you need to mark sun only. If it is not there, in the given options, whichever is far and it gives light, you have to take that object. Understood? Now, let me take the object at infinity. Then I will require minimum of 2 incident rays to take the image. And those 2 incident rays also, first ray, I always take the ray which is parallel to principal axis. Like thumb rule, you can remember this. First ray is always parallel to principal axis. That means it reflects, and the reflected ray will pass through focus. Correct? Reflected ray will be what? Passing through focus. Very, very important. And second ray will be changing for every diagram, and how it changes also we will see as we are learning them. Okay. Now let me draw for the first one. Concave mirror I am taking. Okay. This diagram you have already seen. Whatever I am drawing now. I'm just marking. As I told you, you just need to use your scale and take 2 centimeter and 2 centimeter. Then only it comes correctly and neatly. Whenever you take parallel rays, what happens? All the rays will be reflecting and meeting at one point. This we have already seen. So this point is focus. So arrow marks are important for incident rays and reflected rays. Okay. So this is the first ray diagram. I have done very fast because this we have already learnt how to draw. Okay. So here observe carefully. Object is where? At infinity. O is at infinity. Where is the image formed? At focus. And focus is a small point. So image will be a point-sized image. Highly diminished. Diminished is the term you have to use for small size. Point-size image, that is highly diminished. Okay. And what type of image? Whether it is real image or virtual image. It is real because it is formed due to the real intersection of reflected rays. So it is real image. Okay. Then real images will be inverted. What is inverted? We will see in the next diagram. Remember, it is inverted. Okay. Understood all this? Now we will see what is the application for this. So here we have object at infinity and image is formed at focus, and it is very small. As we have seen, the sun rays we can converge at this point. So have you seen, we generally use solar cookers or dish antennas also they take, like Tata Sky, all of them will be there, right? So if you observe this dish antenna, how it will be? It will be like this, concave, and the antenna will be here. So from the satellite, the rays will be falling on this like parallelly, and they will be meeting at this point. That's why they take this as the shape for the antennas. In the same way, solar cookers also. Why is this solar cookers used? Because heat of the sun to be concentrated at one point. So if you take the concave mirror, the reflecting surface should be like this, concave. Then whatever the light rays falling on it, what it does? it will make them converge at one point. So at this point you will have, here is the box. At this point, if you place the vessel here, it will be heated up fast. Understood? Understood? So this is the application for the first case. And the second one, we have object placed beyond center of curvature, beyond C. This also can be taken as between infinity and center. Both are same, but generally beyond C you take because it will be almost near to the center of curvature. Okay, then see here, pole, focus and center. Then where is the object? Here you have to mark the object. For infinity we need not to mark because that is very far. Here you need to mark, this is the object O. And then we are taking an object of certain height h. Okay, now in the diagram you need not to mark these two also. Simply for your understanding I am telling. As we told, we take the object with single dimension, which is height, and the object is always placed above the principal axis. Okay, understand this. Now let me draw the first ray. First ray is parallel to principal axis and it will be passing through focus. This is the reflected ray. And then second ray, I will take the light ray which is passing through center. That means which is in front of the object. The point what we know is only center, focus and pole, correct? Those are the points we know. In those points, in front of the object, whatever point you have, through that the light ray should pass. Understood? So that it will be easy for you to remember. And don't think that if you take any other light ray, that means if I just take passing through focus, that is also possible. You will get the image. Okay, now I will teach like this for my students generally to take this light rays. Okay, now I am taking through center. Okay, this is the light ray I have taken. Through center means it retraces its own path. You should remember this. I and R, both of them are here only. Now you have point of intersection of reflected rays. Observe R and R. These two are intersecting at this point. So this point you have to join from the principal axis. Now this is the image for you, and this arrow mark which is the head of that line you have to join to the point of intersection. Understood? So now this is the image. Where is the image formed? Between C and F, correct? And the size, when you compare with the object, it is smaller size. So characteristics of image are, position you understood. Image is formed between C and F, and the characteristics are, it is also due to the real intersection of reflected rays, so that it is real image. And if you observe the heads of the object and image, for object it is upwards, for image it is downwards. So this type of images are called inverted images, and all real images are inverted. Remember that. Okay. And the size is small size, so we write it as diminished. Understood? These are the characteristics of image and position of the image. Then what is the application? Where do you see them? object which is beyond C, and you will have a small image between C and F. Some films or magic tricks, they use these applications. Now we will see third one, object placed at center of curvature. Now take the mirror and draw principal axis, mark, pole, focus and center. Okay, now the object is placed at center. The first ray is parallel to the principal axis and passes through focus. And then the second ray is which is in front of the object, that means through focus, correct? When you take through focus, after reflection it will be parallel to principal axis. Now here you have image formed. Actually it will come exactly at the same position with the same size. Okay, arrow marks are important, very very important. Don't miss them. Okay, if you are not drawing the arrow mark, we don't understand which is incident ray and which is reflected ray you are taking. Okay, so these two are incident rays and these two are reflected rays. Now image is also forming at C only, and it is real image, inverted, and then we have same size. Understood? Very very important. And then we'll see fourth one, object at between center and focus. Between center of curvature and focus, let's draw this. It is like opposite to where we have drawn beyond C, correct? Then the image is formed between center and focus. Now when you place between center and focus, where will be image formed? Beyond C. Pole, focus and center. Then I am taking object between center and focus. The first ray is parallel ray to principal axis and it passes through focus I and R. Then let me take the other color for second ray. Now in front of the object, what is the ray we have? What is the point we have? Focus. So through focus you need to take the incident ray. Then draw the reflected ray parallel to principal axis. This is R. Now this is the point of intersection. Join from the principal axis. Now this is image. Where is the image formed? Beyond C, correct? And then what is the nature of the image? Real and inverted. And the size is enlarged, that means bigger. Or this enlarged can be called as magnified. Understood? Magnified is the term. How for small diminished we have learned, for bigger enlarged or magnified. This term you have to use. And this is real inverted image. This is important case where we have real inverted image and that is size bigger than the object, that means enlarged. Okay, and we'll see fifth one. Then object is at focus. Now take the mirror. Let's see points, pole, focus and center. Now I am taking the object at focus, very important case, and there are so many applications even for this case as well. Whenever we take object at focus, that means you can take torchlights, vehicle headlights. Okay, if you place the light at focus, then what happens? First ray is parallel ray and it passes through focus I and R, and the second ray is striking at the pole because the pole is the immediate front point what we know, and this is the reflected ray. Understood? Two reflected rays are moving parallelly if you observe. That means if you extend them somewhere they meet. That's why we take the image formed at infinity. When somewhere at infinity, if they are meeting from principal axis, if you join that point, you will have a very big real inverted image. Correct? So real, inverted and highly magnified or highly enlarged. Any one term you can use. Okay. So this image will be formed. Now let us see the applications carefully. Whenever we have a concave mirror like this, here at focus you place the bulb. That means what? From focus you have all the light rays, they will fall on the reflector. Correct? This is concave reflector. That means what happens? All the reflected rays will be parallel to principal axis. That means you will get a parallel beam of light. Understood? Now this parallel beam of light will make you see very far distances. Correct? So where do you observe them? You can observe them in torchlights. If you have any doubt, just on the torchlight and see. Are vehicle headlights. Understood? Even bed lamps if you take, it will have like this concave reflector only. Or study lamps also you take. Searchlights also you take. Okay. Or in the mines and all people will work, right? Even they put one cap for that light will be there. All of them will give parallel beam of light to see what is there in front of them. Understood? So this is the application when you place the object at focus. Understood? So it gives the parallel beam of light. Then we will see last one and very important, and the sixth case and the fourth case, comparison is also very important. Okay, now see, object is between focus and pole. Let me draw the diagram. Why it is important and what is the relationship with the fourth case you will understand now. Very important even for numericals. Until now we have not learned any numerical in light chapter, correct? Once we finish this, we will go to the numericals. Then where I am placing the object between focus and pole, What is the first ray? Parallel ray to the principal axis. After reflection, it passes through focus. This is the first reflected ray. And then what is the next incident ray I have to take? That is the point. First I have to check the point which is in front of the object, that is pole. Let me take the incident ray at pole, that is one incident ray, and after reflection it will be like this. Correct? Now these two reflected rays, if you observe, they are going in different directions. It is going here and it is going here. Then they don't meet in reality. So this case you have to extend the reflected rays behind the mirror. Now I am extending them behind the mirror. So they are meeting somewhere here. So join it to the principal axis. So this is image now. Where it is forming? It is forming behind the mirror. And it is virtual image. How it is forming? It is forming due to the extended rays, extended reflected rays. So it is virtual image and it will be erect. Understood? And observe the size. Object and image. Image is bigger, so it is magnified image. Understood? Now observe the difference between fourth case and the sixth case. Fourth case, object is placed between center and focus and it is forming magnified real image. And in sixth case, object is placed between pole and focus, then it is forming again magnified image, but it is virtual image. Their image is real and here image is virtual. And let us see the applications. Very, very important. Here for this they will ask you applications in the questions. Okay. Now this will be used mainly makeup, salon, dentists, because they need to see the object in the bigger size. Understood? So here when you are doing makeup, your face will be enlarged. In the same way, dentists, when they are observing your teeth, it will be seen big. Understood? So they can easily identify the problem with the tooth. Now, in the same way, on the face, they will do makeup evenly. Understood? That's why these are important. If you have any chance to see this mirror, just find out and see your image how it is. Understood? Now we will do image formation by convex mirror. It is easy, only two cases will be there. Okay, image formation by convex mirror. Okay, now the first one is same object at infinity. This also we have already seen, so I will do quickly. Convex mirror, and when I am doing convex mirror, we have to be careful by marking pole, focus and center behind the mirror. Now take the parallel beam of light. Same. I and I. Then now what we have to do? Normally center, this I have already shown you, right? So you will have reflected rays like this. Then if you extend them behind the mirror, they meet at one point. This is focus. So image is forming at this focus. So the image is formed due to the extended rays, extended reflected rays. So this image is also virtual erect image, and the size of the image is point size. Understood? This is also very, very important. And the next one, second case, we have object between infinity and pole. Anywhere you take for the convex mirror. Okay. So this also has many, we have many applications for this also. Now I am doing convex mirror. I am taking principal axis and marking points, pole, focus and center. Then somewhere here I am taking the object. Okay. First ray is same here also. Parallel ray to the principal axis, and it will appear to diverge from the focus. So here it appears like this, I and R. And second one, I am taking light ray striking at pole, so the reflected ray is like this, I and R. When you learn the ray rules properly, it will be easy for you to draw any ray diagram. Now extend this reflected ray also behind the mirror. Now this is the point of intersection. Join it to principal axis. Now observe, this is the image. Now image is forming behind the mirror. Correct? And it is also due to the extension of reflected rays, so virtual and erect. And then size, if you compare, diminished. Correct? Anywhere you take the object between infinity and pole, you will have same characteristics for the image in convex mirror. So due to this, we use this mirror in shopping malls or theaters, parking slots, okay, and corners. Especially for parking slots, corners they will place this. Even metro stations also, you might have seen a very big mirror will be placed. And also you can see this mirror at the sharp turnings of roads, because it has a very high field of view. Field of view means, now see here, if there is any ray falling at this corner of the mirror and this corner of the mirror, the reflected ray will be here. Correct? Now the space between the last rays, the last reflected rays, this space is called field of view. That's why it has very large field of view. In between here and all, whatever objects you have, they are seen in this mirror, and they will be very small size, and they will be erect as well. Correct? So For rear view mirrors also, means vehicle side mirrors will be there, right? We use this only. You can see very big vehicle also. It's a small image will be seen in that mirror, and it will be helpful for the driver to see what are the vehicles coming behind. Understood? So this is the main advantage. It has very large field of view, and it always gives virtual erect and diminished image. Understood? And then one more thing, ambulance also, just learn it. Ambulance in the mirror we see like this, but on the ambulance how do they write? They write laterally inverted. Correct? Because in the mirror for driver, it will be easy to read it as ambulance, so that the driver will give space for the ambulance to go. Understood? Next, let's see image formation by concave mirror first, and then we will see with convex mirror. Okay. Anyhow, first case we have already learned. I think you remember that, but let me just show you once. Now, if this is the concave mirror, you have beam of light, parallel beam of light to the principal axis. Now, it will be meeting at one point, this point. All the light rays are taken from a very far object which is said to be infinity. Like we take here sun. In the option, if the sun is not there, any far object we take. Now from this far object we have all the light rays which are parallel to the principal axis. That means let me draw principal axis here. Pole. So on the principal axis at one point all the reflected rays will be meeting. These are the reflected rays. So this point is called focus, and now here the reflected rays are meeting here, so that you will have image also at focus only. And observe the size, it is just a point size, very small image is formed, and this image is formed due to the actual intersection of reflected rays. They are actually meeting, correct? You can directly see them. That's why this image is called what? Real image. Understood? This is the first case. Now let's see the second case. For the second case, we don't take all light rays parallel to the principal axis. Now let me just draw principal axis. Okay, somewhere here let me take this as the principal axis. Okay, then let me first take one object where we will take, we have to take beyond C, correct? Now let me just take here, let me just take here pole, here focus, and here center. Somewhere here I am just taking object. Understood? Now first ray, parallel ray to the principal axis, it has to pass through focus. One second. Pole, focus, and center. Beyond C we have object. Okay, and then let me take the light ray. I am taking the light ray from object. I'll take light ray here. Okay, this ray is not there. Here I have to take the light ray. parallel ray to the principal axis. Okay. It has to be parallel to the principal axis. 1 second. Let me shift it here. Somewhere here I will take light ray, parallel ray to the principal axis. So wherever it is touching, that is the focus point. Okay. Now the second ray you have to take from the object only, which is passing through center of curvature. Okay. Now center means we know it has to retrace its own path. Correct. Now, so this. Now observe here, where is the image formed? Image is formed if you take this as the focus and this as the center. Where is the image formed? Object is beyond C. Where is object? Beyond C. Correct. See here. Now, image is formed between C and F. Where image is formed? Between center of curvature and focus. Observe the size. It is diminished. And how it is formed? It is formed due to the real intersection of reflected rays. Correct. This is I1 and this is R1 and this is I2 and this is R2. Because it is center, it has to retrace its own path. Correct. Now they are meeting at this point. Due to real intersection we got the image. That's why this image is real image. And observe the heads. Object head we have taken like this and from this we have taken the light. Now image head is downwards. That means it is said to be inverted image. Okay. Now all the real images are inverted and they can be taken on screen. First itself, while learning concave mirror, we have learned while learning why it is converging mirror. Correct? Because we can take the sun's small image on a paper. Here we can take paper as the screen. Understood? Now real images can be taken on screen. Understood? Next, this is. Let's see the image formed by concave mirror when the object is placed at center of curvature. Before this, we need to know where is center of curvature for the mirror. Correct. For that, what I am doing is, first I will find out the focus point by taking a parallel ray to the principal axis. So now, parallel ray I have taken, it is meeting at one point to the principal axis. So that point, the reflected ray is meeting at one point on the principal axis. So that point is taken as focus. Now let us measure the distance between the focus and the pole by using ruler. Okay. Now see here. If you use the ruler, it is touching at 7th line. That means 70 millimeter we can take. Now the same way you should have the distance from focus to center also. Correct? Now this point is the center where exactly you have 0. Now let me take the object there. Okay. Object is where? At this point, at 0. Okay. Now the light ray has to pass through focus now. Correct. The second light ray should pass through focus from the object. Now the object is at 0. I am taking the light ray. Light ray from 0, it is passing through from 0 only we need to take, and it has to pass through where? Focus. Where is focus? Here. Now see here, we have object at 0 here. From object we have first incident ray I1, which is parallel to principal axis, and the reflected ray is passing through focus R1, and the second incident ray is this ray, which is, I am doing with a different color. This is I2, and its reflected ray is parallel to principal axis, which is R2. Now where they are meeting? This is the point they are meeting. Join from the principal axis. Now observe, it is the center, correct? This is focus, this is pole. When the object is placed at center of curvature C, image is also formed at C only, and this is formed due to the actual intersection of reflected rays. So it is real image and it is inverted. Understood? Then what is the size? Same size, that means equal as object it will form. If you see the diagram also, you will understand. Okay, so this is the nature of the image formed when the object is placed at center of curvature. Whenever you are drawing the ray diagrams, make sure that you will take the same distance for focal length and from focus to center. In your notebook or while writing in the exam, you can take 2 centimeter and 2 centimeter, or take 3 centimeter and 3 centimeter equally like this, so that you get diagram neatly. Understood? Object is taken here between center and focus. Then light rays are same, correct? One is parallel light ray and the other one is parallel light ray. Then the reflected ray is passing through focus. That is same for all the objects. Now this one is, which is passing through focus. The second incident ray is passing through focus and its reflected ray is parallel to principal axis, and they are meeting here. Correct? If you just join here, it is beyond C. Understood? It is what? Beyond C. C is here at 0. Now where is the image found? Beyond C. And tell me the characteristics of image now. Image is formed beyond C, and size, if you see, it is magnified, bigger. You can identify as well. Magnified image. And then what do we have? Real only, because the reflected rays are actually meeting and it is inverted. Understood? Very, very important. This case is also very, very important. This is fourth case, because in concave mirror we have two cases, magnified images. So this is one and this is real. Understood? Important. You have to remember this ray diagram as well. Practice it very well, and numericals also. On this you will have so many numericals. Understood? Now let me do for the next one. That is, the light ray will be parallel only wherever object is, we know that, correct? Now the object is at focus. This is the focus point, you know, right? Now when the object is at focus, the light ray, what do we take? We take striking at pole, correct? Now the object is here at focus. Then we have light ray falling onto the pole. Let me take light ray like this. See here, the light rays, you can see them as parallel. You can see them as parallel, the reflected rays. R1, this is I1, right? This is R1. This is I2. So because we have object here. And this is R2. Understood? R1 and R2 are parallel. That's why what we are considering, we are taking them that they meet at infinity. So at infinity we have image formed. Understood? At infinity we have image formed. Whenever image is formed at infinity, what will be its size? Infinity means very big. Correct? So the size will be highly enlarged or highly magnified. Then this image is also taken as real because we are considering that they meet in reality at infinity. Understood? Real. And then we have inverted only. All real images are inverted. We know that, correct? Understood? Now this is the fifth case. Now let me take sixth case. Here what you have to mainly focus is about reflected rays and the incident rays and the object positions and whether they are meeting in reality or not. Understood? This is what you have to see. We'll see sixth case. What is the sixth case? Object is between focus and pole. Now object is here. Understood? Now the incident ray has to be from this point, somewhere here. Incident ray also should be from the pole. Now observe here, this is first incident ray parallel to principal axis and this is passing through focus. So this is reflected ray. Now this is the second incident ray and this is the second reflected ray. Now by seeing itself you can see they are not parallel, instead they are going in different directions so that they don't meet in reality. Can you see the distance is increasing? So if you extend them until infinity also, their distance will be increasing, so they will be separated. Correct? Now what you have to do, you have to extend the reflected rays behind the mirror. Extend them behind the mirror. They are meeting at this point. Now join this to the principal axis. Now observe, if you have object here and image here, where is image formed? Behind the mirror, correct? And how is the image formed? It is formed due to the extension of reflected rays. So this image is called virtual image. What is this called? Virtual image. Then these virtual images will not be taken on screen and they will be always erect. Now observe here, if you take object like this upwards, the image is also upwards. Whenever we have seen until now, until fifth case, the images are formed in front of the mirror and they are formed below the principal axis, correct? Now, where is the image formed? It is above the principal axis. So, this is called erect image. Okay. When the images are below the principal axis, they are real and inverted. Above the principal axis, they are virtual and erect. Understood? So, this is also very important case in concave mirror. Understood? Next, we will see for convex mirror. In diagram, you already understood, correct? In simulation, I am just showing how the rays will be moving and incident rays and reflected rays, how they will be shifting. That is what I am showing in simulation. Okay. Now concave mirror we have completed. Convex, let us see. Convex we have only two rays, correct? I mean two ray diagrams and the two rays are minimum required. Now let me show you with convex mirror. This is the convex mirror. First case is when the object is at infinity, we have to take parallel beam of light. This we have already seen. I think you remembered this. Parallel beam of light. When I am taking parallel beam of light, what happens? They will be moving in different directions, so that we have to extend them behind the mirror. I am just extending these reflected rays. Somewhere they will be meeting. This point is called focus and center will be here. Understood? Understood this? If you don't have these also, you with scale you join. They will be joined at that particular point. Okay. Now let me show you. Okay. We will also take ruler here and join. With straight line also you can take and join anything. Small variation is there. Now this is one more reflected ray. And this is one more reflected ray. Have you observed? They are meeting at one point and this is that point. So this point is what? Focus. Understood? This focus is due to the extended rays. That's why this is called what? Virtual focus. Here you will have image formed. Focus is a small point. So here what type of image will be formed? Virtual erect. Because virtual focus, virtual erect image will be formed and it will be point size only. Understood? And where it is formed? At focus. When the object is at infinity. Whenever we are taking parallel beam, remember it is the infinity position. Whenever we have object at infinity, whether it is concave mirror or convex mirror, image will be formed at focus only. But concave mirror, it forms real image and real focus. In convex mirror, it forms virtual focus and virtual image. Understood? This is the first case. Let's see the second case. What we have for convex mirror. The second case is what? We have object placed anywhere between infinity and pole. Correct? Now let me take the principal axis and just we will take one object. Let me take this as object. Now let me take the light ray. Now parallel ray I have taken. It is diverging. Correct? Then when we have the other ray, what you have to take? Striking at pole. Correct? Striking at pole. Striking at pole. Slowly we have to do. Almost it is striking at pole. Okay. Now, will they meet in reality? See here. This is the incident ray and this is the reflected ray, and this is the incident ray and this is the reflected ray. This reflected ray is in this direction and this reflected ray is in this direction. They don't meet in reality. So what we have to do? We have to extend them behind the mirror. Let us extend them behind the mirror. Reflected rays I am extending. Now this is the point where we have the two extended reflected rays are meeting. So this point you have to take. Understood? So this is what? Image. Where is image formed? Behind the mirror. Yes. And what is the nature of the image? It is formed due to extension of reflected rays. So it is virtual image. And how it is? It is above the principal axis. So it is erect. And what is the size? This is object size and this is image size. If you observe, image is smaller. That means it is diminished image. So the mirror which produces always diminished image for any position is convex mirror. The mirror which produces always virtual erect same size, that is plane mirror. Understood? Diminished means you have to get, in case of virtual, diminished is convex mirror. If it is virtual, erect, same size, plane mirror. Understood? So these are the image formations by spherical mirrors. I hope you all understood this. Sign convention of spherical mirrors. This sign convention is very important to learn for solving the numericals of spherical mirrors, and it is very easy. The sign convention is called as new Cartesian sign convention, and this is our graph. Okay, we'll see how it is. If you just take a graph paper, you will know, you will just take x-axis and y-axis, correct? Positive x, positive y and negative y. Then we have origin here. Here what we have to do is, we can take the mirror here. Then the origin will be acting like pole. Our pole will be considered as origin. and then you just need to take the reflecting surface and the silvered surface. Then object where we place? We place always in front of the reflecting surface here, and it will have certain height, correct? From the object only we have light rays. Light rays. So this is the direction of light. Correct. Now, first point what you have to remember is all the measurements are done from pole only, and x-axis is principal axis, and the object is always placed on the negative x-axis only, and it will be above the principal axis. Understood? Now this is one distance, this is one distance, this is one distance, and this is one distance. Only 4 distances we have, and they are always measured from pole only. From pole right side is positive, from pole left side is negative, above the pole is positive, below the pole is negative. Only this much you have to learn, because whenever we have virtual images, they will be here on the positive x-axis. Whenever we have real images, they will be always on the negative x-axis, and virtual images will be above the positive x-axis, and real images will be below the positive x-axis. That's why we just need to learn this much only. While learning the problems, you will easily understand how we are taking the sign convention. Okay, now in your textbook it will be given as the distances are measured from pole, and the distances measured above the principal axis are positive, below the principal axis are negative, and the distances measured along the direction of light. That means you don't need to take this here on the negative x-axis, because remember distance is measured from pole, so along the direction means here you will get. Understood? Positive x-axis you will get, don't get confused. Here this is along the direction of light. When you are considering negative x-axis, this is the opposite direction of light. Understood? So the distances measured along the direction of light are taken as positive. Opposite to the direction of light are taken as negative. Understood? So this is the sign convention. If you know the graph, it will be very easy for you to take the sign convention, and we will understand more while solving the problems. Okay. For convex mirror also it is the same. I'll just draw convex mirror and you will understand here itself. Convex mirror, how you will draw? You have to draw like this. Convex mirror will be like this. So the same pole you will have. Understood? Only that much you will learn while solving the problems. And next, mirror formula. So mirror formula gives the relation among object distance, image distance, and the focal length. We have already learned object distance is denoted with letter U, correct? And image distance with letter V. And you know already focal length is small f. So the relation among these three is given by mirror formula. We write mirror formula now. Very, very important. 1 by f equal to 1 by v plus 1 by u. or you can take 1 by u plus 1 by v also. Both are same, correct, because it is addition. 1 by f is equal to 1 by v plus 1 by u, where f is focal length, v is image distance, and u is object distance. And one more formula we have, that is magnification. So magnification gives whether the image is bigger or smaller when it is compared with the object. Understood? So magnification is denoted with letter M. It will be minus v by u, which is equal to height of image by height of object. You know what is v, correct? So M is equal to minus image distance by object distance. Okay. And then height of image by height of object. So it is simply a ratio, and it is a pure ratio. That means if you take image distance and object distance, it is distance. So meter will be cancelled. A centimeter if you take also, it will be cancelled. In the same way, heights also same. We generally take centimeter only. So the units will be cancelled. So magnification doesn't have units. So no units for magnification. But for focal length, object distance, and image distance, you have to write the units. Whatever units they will give, like meter or centimeter, because it is distance only, correct? Then we will see some problems, and in the textbook how they have given the lesson also we will see with a small video next video. Okay. Thank you for watching this video and subscribe.